All right. Um, as I said yesterday, everything kind of went to hell there for, well, about a week straight. Um, I've got all of your daily work and stuff taken care of, aside from the handful who did not turn things in. There is more red showing up in the grade book in terms of missing things than is typical for a pre-calc class. It appears to only be happening in first hour. Y'all, do your work. Okay. Um, I know some of you who ignored remind and did not do what you were supposed to on Friday, were caught off guard yesterday. I hope that quiz went okay. We'll see. But the plan right now, y'all know we're already at almost quarter. We got quiz 5 was yesterday, 2.5 will take us probably 2 days. 2.6 will probably take us 2 days. 3.1, and then you'll do quiz number 6, and then end of the third quarter, and you get a 4-day weekend next week. Okay? So it's already there, which means another grade check coming up. I'm going to be in the next 3 days going on that grade-a-thon again. We'll try to get your guys' quizzes in. There's 2 of them now. As soon as they're in, I send out the text on remind, let you know where everyone stands, send out that cute little bar graph. So you don't have to be pestering, are they in, are they in, are they in? You don't have to be checking campus every hour. Just wait for the text. When it goes in, check. Okay? So, finally, we get to 2.5 rational functions. When I say finally, it's because up until now, haven't they just kind of assumed that you knew some of this stuff? Now, if you came straight out of Algebra 2, and we've said this a bunch of times already, then yeah, it was fairly familiar. But if you're one of those unfortunate souls who took Algebra 2 last year, then you're like, I haven't seen this since Algebra 1. For some of you, that's 8th grade. So it's been a trip trying to remember that. Today and tomorrow, we go through all of it in detail. So, rational function. Rational function, anything that can be written as a fraction. We've already run across this, particularly with our continuity. Remember the whole removable factors is removable discontinuity. Set denominator equal to 0, that's my infinite discontinuity because it makes asymptotes. Okay? So you have vertical and horizontal asymptotes. Vertical asymptotes. If you want to write zeros of the denominator, that's just it. Set the denominator equal to 0, that's where your vertical asymptotes are going to be. Sometimes a rational graph will alternate on either side of a asymptote. Sometimes you get the butt crack graph, where they're both up top. Notice that happens when they're even powers, because anything squared is going to be positive. That puts all of it up top. Sometimes you get some really goofy looking ones. Okay. Horizontal asymptotes, up until now, horizontal and vertical asymptotes are the invisible line that you cannot cross. Think second Hunger Games. You know, seen that one? Like the fog bank of death that's going to melt their face off. And she falls down the hill, and here comes the fog, and it's going to, and it hits that invisible wall. That's what an asymptote normally is. Okay? Normally. I say normally because vertical asymptotes you will not go through until Calc 2, maybe? But starting today and tomorrow, we can go through horizontal and oblique asymptotes under the right conditions. Okay? If there is a solution to the system, horizontal line, y equals thing. If y equals thing happens to be a solution to the numerator of that function, sometimes you can go through those asymptotes. It's like T'Challa saying, open the shield, and that one area it's able to sneak through. Okay? But most of the time, it's going to be that invisible line that you don't cross. So, find the domain, vertical and horizontal asymptotes. Domain. We are still adhering to our commandments of domain. And the first one is, thou shalt not divide by 0. So if I'm not allowed to divide by 0, I'm going to set my denominator equal to 0 and solve. That is the one guy that's going to break my rules. Okay? My rules are simple. Don't eat my goldfish. Caden's going to eat my goldfish again. He's not allowed to come to my party. Okay? So my domain will be negative infinity to 3. Can't touch us. And 3 to infinity. Okay? Hi.
Can I take a test during this class?
What? Which one? I thought you took it yesterday.
Quiz 4, the one before class.
Oh. Where are you going?
This is in here. Nowhere.
All right, if you just want to plop on over there, go for it. So I got a domain there. That means my vertical asymptote is also there. Okay, so you write vertical asymptote. Remember, the vertical asymptote is a line. So lines have equations. So I'm going to say vertical asymptote x equals 3. Don't just say 3. It's x equals 3. Just like when we had our axis of symmetry on a parabola, we didn't just say 3, we said x equals 3. Okay? Then it's going to ask me for any horizontal asymptotes. And if you don't remember the tricks to do rational functions, well, off to the calculator we go. Clear. Set up fraction, x plus 4 over x minus 3. Right? It was plus 4? Yeah. Okay. And I graphify. Okay, now depending on what type of calculator you have, it's going to change what it's showing. I know a couple of you are running 84 pluses, the old silvers. Even a handful of us are running the old 83s. On those, there is a line at 3. They actually show the asymptote. They stopped doing that with the CEs because it confused some kids and they thought that was actually part of the graph. Okay? So I know on the 83s, it'll show a vertical line there. On the pluses, is it showing that vertical line? Okay, so they got rid of it there. Just be aware of it, whatever model you're using. So we got a vertical asymptote here. There is a horizontal asymptote. You see how it kind of curls along this invisible line, but where is it? You think it's 1? So, test it. Stick a 1 in there. Don't look too bad, right? It doesn't hit that. Maybe my window, what if I go out to like negative 30 to 30? Will it ever cross that line? Looks pretty good. How can I confirm that y will never be 1? Okay, yes, there's the trick for it. But I can confirm that y is never going to be 1 by plugging in y is 1. And it'll show me that that's not possible. If I say 1 is x plus 4 over x minus 3, cross multiply, subtract x from both sides, that's impossible. So I know that y can't be 1. So I'll say that there's a horizontal asymptote at y equals 1. And yes, there are rules for it that we learned, most of us learned in Algebra 2, but if you know the rules, by all means, go ahead and use them. If you don't remember the rules, then you're just going to have to stare at that screen and hope for the best. I think it's this. Try it, see what happens. Okay? Again, domain. Set your denominator equal to 0. So where's my vertical asymptote? Non-real. There are no real numbers that are going to make the denominator 0. So there's no vertical asymptote. There's no exclusions to my domain because there was no real number that made this not work. So my domain is all real numbers. There's no one that's going to break my rules. Maybe my rule is you can't teleport to the moon and back in the middle of a game. Well, unless someone can do that, that's okay, it's not going to work. So that means my vertical asymptotes, there are none, but there is a horizontal asymptote. If you know the trick, go ahead and use it. If you don't know the trick, start poking buttons on that calculator and see if you can figure out what is that horizontal line that this thing won't cross. Clear. We'll say 8x squared plus 5 over 4x squared plus 1. Clear this out. Okay. I heard looks like 2. Well, it's got to be awful close to 2, but that looks like it's almost right on the line too. Okay. Another way that I can check this, I don't know. It looks like it's right on top of it. Check this out. If I go my window real big, make my window big again, 30/30, and let's say I'll calculate an intersection. If it hits 2, I should be able to say intersection between this and this, and it'll tell me where. So somewhere between yellow thing, blue thing, poke the button, and it tells me, nope. A sign change, meaning it went from positive to negative if that line is considered 0. So it never crossed that line. I can also plug in 2 and show you this doesn't work. Cross multiply, 8x squared plus 5, those are expensive, be careful. 8x squared plus 2, again, I get 5 equals 2, which is not possible. So I know that 2 is not allowed. So then we'll come over here and say that there is a horizontal asymptote at y equals 2. Okay? Sometimes there isn't a horizontal asymptote at all. Sometimes it's oblique. Sometimes I have to change the window to see my entire graph. If I remember correctly, one of these two down here, yep, you're going to have to monkey with your window here. Remember that these graphs, at a minimum, are going to have 2 portions to them. Change your window around until you can see the entire graph. Go. Find what is your domain, what are your vertical and horizontal asymptotes if they exist.
powers or the coefficient?
The powers on the leading terms.
Okay.
Yeah, because if they're the same, can you divide by it? And if it's different, like you divide by the coefficients.
Okay, so we're about to get the rules right after this, but yes. There are rules. The book wants us to keep doing this the hard way for like 3 different examples, and then they give us the rules. Nah, you just do these 2, and then we're going to give you the rules. Oh, randomly, are any of you missing a like an earring or a nose ring or something? I'm scared what part of anatomy it came out of, but this was left on my desk by the custodian. Anyone? Okay. All right. 3/5 and negative 1/5. Yeah, that's right. -4, 1, -4, -5. Okay. So that's what they end up looking like. First one. I set my denominator equal to 0 and solve. I think we're all good with that part. My domain, -infinity to -5, can't touch us. And -5 to infinity. Which means I have a vertical asymptote at x is -5. Again, remember to actually put it as a line, like x equals, don't just say -5. My horizontal asymptote. Some of us are remembering the rules. We're remembering the ancient ways. Yes, I can just take leading coefficient divided by leading coefficient when? When the degrees are the same. We also talked about that earlier when we were kind of like half reviewing it as we did some of these in our continuity stuff. Yes, y equals 15 is the horizontal asymptote here. But you weren't going to see that if you didn't make your window bigger. Right? Normal 10 by 10, you just would have seen this, and that's it. You had to make your window bigger to see the rest of the graph. Same with this. If I don't make my window bigger, I only see part of the graph. Set my denominator equal to 0. We're going to have a domain of negative infinity to negative 4. Can't touch this. And negative 4 to infinity. I have a vertical asymptote at x equals negative 4. And there is no horizontal asymptote because it follows this kitty corner line called an oblique asymptote. In this case, it is y equals x minus 5. Minus 4, yeah. Okay, so I'm going to say there is no horizontal asymptote for now, and that's all you would put. Okay, until we learn the rules. And again, I'm just going to bypass their do it the hard way stuff. We're going to go straight to the rules. Okay, the rules, if you do not remember them, okay, we'll just come back to this because they involve all three rules. All right, here, and it's all written in mathese. Okay. Up top, you see how that's just that polynomial definition in sequence notation again? So they're saying if I have a rational function such that they are polynomial over polynomial, then what I'm doing is looking at my leading terms. Okay, right below this, it tells me my three rules. Rule number 1, if n is less than m, if the degree of my numerator is smaller, then y equals 0 is going to be my asymptote, my horizontal asymptote. And that's because when I try to divide numerator by denominator, and the denominator is a bigger degree, it goes in there 0 times. Okay? Rule number 2, when they're the same degree. Well, now if I take x to the 4th divided by x to the 4th, I just have to worry about those leading coefficients. I'm going to have y is a over b. My leading coefficients will create a horizontal asymptote. Go back to the last 3 that we did that had horizontal asymptotes. Weren't all of them x to the 1st over x to the 1st, x squared over x squared? Look at what their asymptotes ended up being. 1 over 1, 8 over 4, 15 over 1. Okay? As long as the degrees are the same, that works. Where it gets dicey is rule number 3. In rule number 3, oh, it's right here. Okay. In rule number 3, if the numerator has a greater degree, there's not a horizontal asymptote, there's an oblique. Okay? So I'd like you to write next to this one, there is no horizontal asymptote. I divide, ignore your remainder, there has to be a remainder, because if I take numerator divided by denominator and there's no remainder, what does that mean? We just got done doing a bunch of these. If I divide and the remainder is 0, it's a factor of. If it's a factor of, that means I could have canceled the factors and there would have been a whole instead. So I'm going to divide, I'm going to ignore the remainder, and that's going to get me an oblique asymptote. Now go look back at 1b, the one that I just did that had the oblique asymptote. See how it was x squared over x to the first? The degree of the numerator was greater, so I'm going to have to divide. If I take x squared divided by x to the first, I get x to the first. That's why it was a line as an asymptote. You won't get them in here. I think there's like one challenge example. You won't get them in here, but specifically they say if n is m plus 1, you get a linear asymptote. Well, what happens if it's 2 degrees higher? You can have a quadratic asymptote. You can have a cubic asymptote. You can have a quartic asymptote. Now you're talking like Calc 1 through 3, where it's entirely possible that this one and this one, maybe this guy has an asymptote here and here and here, goes through an oblique and does this. We're going to get those in a few minutes. Versus you could have ones like this. That ain't in PreCalc, that's further on. But it is not unheard of to have this as your graph. It gets funky. Real funky. Okay? Now, we aren't going to do this. I think there might be one challenge example like that, and it's specifically use your graphing calculator. Okay? So don't worry about those. We're going to get the yellow-green one here. Okay? So those are my rules. Also, next to all of these rules, maybe in this little area, I want you to write, if I do f of x is ax to the n plus c over bx to the m plus b. I don't want to write all the sequence stuff in the middle. Okay? I'm lazy. Next to this, you're going to have the holy grail for rational functions. Zeros of my denominator. We just said those make vertical asymptotes. Gaps in my domain. Riddle me this, Batman. If I want X-intercepts, do you remember how you algebraically find X-intercepts? 0 in for y. Well, if I put 0 here and then have ax to the n, bx to the m, what happens when I cross multiply? Ax to the n and whatever other stuff with it equals 0. So if I want X-intercepts, it's just the zeros of my numerator. Zeros of my numerator will get me X-intercepts. Because when I plug in 0 for y, cross multiply and solve, I end up with numerator equal to 0. My y-intercepts. How do I get y-intercepts? And if I put a 0 in for x, isn't this going to be 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, c over d? So my y-intercept is c over d. Because all the other stuff is going to turn into zeros when I plug in a 0. And then next to it, now I'm looking at my rules. If n is less than m, horizontal asymptote y equals 0. If n equals m, horizontal asymptote is green. Y equals a over b. If n is greater than m, I'll have an oblique asymptote at divide. Okay? Those four things. You're going to find those four things to graph a rational function. You might need to find a couple more points in between, because sometimes you don't really know the behavior of the function. Do the little curve parts, they like to alternate whenever I hit a perpendicular set of asymptotes? They like to alternate sides. But sometimes maybe they're both above. Sometimes maybe it goes through that horizontal asymptote because it's also one of my x-intercepts. We're going to have to find a few more points, but we're always starting with these four. And that's what it says at the bottom of this big note blurb here is, find your domain, that gets you your asymptotes, get your x and y intercepts, go find a couple of more points. Your horizontal or oblique depends on the rules. So, this is just practice, practice, practice. Start with, find your vertical asymptotes if there are any. Are there any? Set denominator equal to 0. And label it, x equals -3 is my vertical asymptote. Okay. Remember, the zeros of my numerator are my x-intercepts. Set your numerator equal to 0. 6 equals 0. That's not possible. So there's no x-intercepts because that's not possible. 6 does not equal 0. If that was 6x equals 0, now x would equal 0, I would have an asymptote at 0. Okay? So no x-intercepts. I can also find y-intercepts. What's g of 0? Toss a 0 in for x. C over d is 2. So I have a y-intercept at 2.
You want us to write that as like a coin pair or
Because I wrote g of 0 as 2,
just
like technically that is my thing, but if you want to write it as 0, 2 coordinate, that's also good. Okay. And then my horizontal asymptote. I go and look at my degree. What's the degree of the numerator? 0, because it's constant. Degree of denominator? 1. 0 is less than 1, so y equals 0. Now, here's another fun part about these. They like symmetry. They really like symmetry. From this crosshairs, we kind of talked about this when we were graphing them in chapter 1. See how from here I went 3, 2? 6 divided by 3 is 2. Dump this in your calculator. Find some other points. I'm betting that -1, 3 is also a point. because it's taking 6 divided by a thing, and I'm going to have all of these, where's my chess players at? It's like all of the knight moves, right? Okay, where it's 2, 3, because 6 divided by 2 is 3. Now I said they like symmetry. I mean, I'm also going to be able to move that far away from here. 2, 3. 3, 2. Double check. Are -5, -3, and -6, -2 also coordinates in that table? Okay? Said these things like symmetry. They like that idea of maintaining symmetry around the crosshairs. The crosshairs of where those asymptotes are. So, I'm going to make a couple more points. So 1, 2, 1, 2, 3, 1, 2, 3, 1, 2. I can also, 6 divided by 1 is 6. 6 divided by 6 is 1. 6 divided by 1 is 6. 6 divided by 6 is 1. I can use that symmetry to find some more points, or I can just look at my calculator and plot some points. I don't care which way you do it. Either way, I've got a few more points. I can connect the dots. I got my graph. Okay. Find your vertical asymptote. Find your horizontal or oblique asymptote, depending on the rules. Find your x-intercepts, your y-intercepts. Check the calculator for a few more points. Connect the dots. Okay? Make sure that you're labeling stuff, though. Contestant 2. Set my denominator equal to 0. Got a vertical asymptote. Yeah. What else can I find? X-intercept. If I set my denominator equal to 0, are there factors of a positive 10 that add up to a negative 7? Okay, so it happens to be factorable. Y'all, sometimes it's not factorable, and you have to write your x-intercepts as compound radicals. Quadratic formula or complete the square, I don't care. You write it for real. Don't you dare just give me the decimal. You're big kids now. Okay? So yes, I can call this x minus 5, x minus 2. So my x-intercepts are going to be at 5 and 2. Zeros of my numerator. Next up, go find k of 0. Remember, if I plug in a 0, all the x stuff is gone. Negative 10/3. Or negative 3 1/3 to ballpark it. Negative 3 1/3 is my y-intercept. Now for that horizontal asymptote. I look at the degree. Numerator is 2, denominator is 1. I check my rules, and my rules say there is no horizontal asymptote, but there's an oblique. So I'm going to divide x minus 3 into x squared minus 7x plus 10. Getting x, change my signs, negative 4x, drop it, little hot. Negative 4x divided by x is negative 4. Negative 4 times the stuff is negative 4x plus 12. Change my signs and I get a remainder. What do I do with the remainder? I ignore it. Remember, there will be a remainder. Now, could I have done synthetic? 1, -7, 10, with 3, 1, 3, -4, -12, -2, ignore. Okay? Now, I do want to be careful with the synthetic thing. Remember that whole, am I looking for the factors? Am I looking for the zeros? Okay, that's going to come into play a few times. This tells me that y equals x minus 4 is my oblique asymptote. So go to -4, slope is 1. What? Oh, yeah. Papa Bear needs to stop eating his feelings. My gut. And then my shirt went over the sensor. It's been a wild few years, y'all. There we go. Now, remember, these things they like to be symmetrical. So from this point, this crosshairs here, if this went left 1, up 1, I should be able to go right 1, down 1. From these crosshairs, if I went up 1, right 2, I should be able to go down 1, left 2. And you see how they're still kind of in line with where that curve is going to be? From this crosshairs, to get to purple dot, my y-intercept, I went left 3, down 2 1/3. So I should be able to go right 3, up 2 1/3. You see it's still along that curve. Okay? I got my x-intercept, my y-intercept, I've got my vertical and my horizontal asymptotes. I put a couple of extra points in there. I connect the dots. And it's good enough. And he did it again. There we go. Okay? So you make sure, if I was looking at this on, I don't know, daily quiz, I would be looking for, is your vertical asymptote correct? Are your x-intercepts correct? Is your y-intercept correct? Is your oblique asymptote correct? Does the general shape of your graph work? Okay?
How do we label the oblique part?
Y equals x minus 4. It's that line. Okay?
So if our oblique was the PreCalc, then it would just be like
Yeah, it would suck. We're not going to have that. Don't worry about it. I'm pretty sure the only time I've seen that in our textbook is a challenge problem. Do this in your graphing calculator. We are not going to manually have to do that. I'm just letting you know it's possible. Imagine vertical asymptote, cubic asymptote.
and then where do you know
You're going to have to test points. Graph by table. But yes, they can get really, really weird. All right. Both of these end up nice. There's no oblique asymptote. Go. There might, however, be multiple vertical asymptotes. Okay, zeros of your numerator, zeros of your denominator. F of 0, follow your rules. Okay, find those 4 things. Maybe a few more points, you're good to go.
Did you put in -3 and +1?
If there's anyone who prefers to have maybe a different color line or something like that for your asymptotes, some kids would rather have that. Got a whole bucket of colored pencils up here, so you don't have to do it in pen and then regret your choices.
Yeah, that's so bland. I was giving you a compliment. Everybody deserves a compliment.
Start with your vertical asymptotes. I don't see any X-Intercepts because I have 2 does not equal 0. If I plug in a 0, I get -2/3 for a y-intercept. And my rules tell me, since n is less than m, y equals 0 is going to be my horizontal asymptote. Now, the question is, where do all of the other things happen? Where's the behavior of this graph? Now, experience tells me that because I've got a y-intercept here, these things like symmetry, I'm probably going to have a point here, a mirror of that point over here, a mirror of that point up here. I'm betting that it looks like this. I could be wrong, but that's my guess, and that's why I'm going to go to my calculator to double check. Yeah, quit. Okay. Y is clear. 2 over x, no, squared. There we go. What was it? Plus 2x minus 3? And I see, okay. So we got the right idea. Oh, and then that other line's still there. Okay. Vertical asymptotes, horizontal or oblique, depending on the rules. X-intercepts, Y-intercepts, check the calculator for behavior. Again, set my denominator equal to 0. X plus 2, x minus 1 equal to 0. I'm going to have vertical asymptotes at -2, +1. Set my numerator equal to 0 to get my x-intercepts. Plug in fn of 0. If I plug in 0, 0, 0, 0, I get 0, which should make sense. I just had an x-intercept at 0, so I should also have a y-intercept at 0. My horizontal asymptote. N is less than m, so I'm going to have a horizontal asymptote at y equals 0. Well, wait a second. How can I have a horizontal asymptote that goes through an x-intercept? I said, this is those rare cases that we're going to start getting. There was a solution in the system between horizontal asymptote and numerator. If there is a solution in that system, it's the gap in that invisible wall. Okay? Y'all seen Infinity War, right? All the creatures of Thanos' army coming up against the shield, and they just say, open this one little area. Commence fight. That x-intercept happening on my asymptote tells me open the shield. That one little area. So I'm going to have a graph that goes through that one spot. My guess, based on prior experience, is it's going to go through like that and then alternate. But I'm going to need some more points to prove that. I might be wrong. So I'm going to go put that in my calculator and double check. Clear. Clear. We had x over x squared plus x minus 2. X squared plus x minus 2, graph of a. Yep, RGB. Now if I want some more points with that, again, I'm going to go to my table. Oh, auto. Oh yeah, it's just in fraction mode. Okay, you see how you're going to have errors where those asymptotes are? Just plot a few more points and you're good to go. Okay? Now I want to show you these are written as fractions because right now my mode is set to auto. I type it in as a fraction, it gives me a fraction. I type it in as a decimal, it gives me a decimal. So if I were, instead of this, to have written x divided by x squared plus x minus 2, like those of us who have to use the old TI-83s and go parenthesis bonkers on it, then when I go to my table, it's only going to give me decimal values because I wrote it as a division problem instead of as a fraction. Okay? But either way, you're still going to get those other points, and you, shoop, shoop, good to go. I don't expect a whole bunch of points because these are going to be really close to the asymptotes, and you're going to be kind of winging it by the asymptotes anyway. So as long as you had, I'd say, like 1 point here, here, and here, good. Okay. So I kind of jumped the gun here by giving you all of the rules. They wanted us to just kind of do this the hard way, plot by points, not even tell us what an oblique asymptote is. So when we go on to the other ones, all the way to example 3, there we go. We can go back to those other ones if we need extra practice. I see the degrees are the same. So, since the degrees are the same, look at my leading coefficients. That tells me I'm going to have a horizontal asymptote at 3. And label it. Example 3. Skipped ahead a slide because we're doing okay. I set my denominator equal to 0. X plus 3, x minus 3 equal to 0. I'm going to have x-intercepts at plus or minus 3. Those are vertical asymptotes. Papa Bear's tired. Okay. I got the text yesterday while you were doing your test that confirmed Baby Bear also has double ear infection. X-intercepts, that's my numerator. There we go. If I set this equal to 0, I'll factor and get x-intercepts of plus or minus 1. That's more like it. And then if I plug in a f of 0, again, all that stuff disappears and you get c over d 1/3. So positive 1/3. Those 4 things. Zeros of my denominator, vertical asymptotes. Zeros of my numerator, x-intercepts. Use your rules for your horizontal or oblique asymptote. Plug in 0 to find your y-intercept. And then you should be good. You see how it's got a little parabolic curve to it? Again, I'm guessing that it's going to go here, here, and here because it likes that symmetry. But I'm going to confirm that by going to my calculator and getting a few more points. Y is clear, clear. Make a fraction, poke. 3x squared minus 3 over x squared minus 9. Get my table. I get some extra points. You see that curve from negative up to 1/3 and down? But I need some more. -5, 9/2. I can work with that. -1, 2, 3, 4, 5. 9/2 is 4.5. And then if you go to +5, you'll get the same thing. Okay. I don't need a whole bunch of points. I've got 1 point there and 1 point there to show where my curve is going to be, right? You are now good to go. because I'm looking for the key features, and if you have just that one extra point in those two quadrants, good enough. Okay? Oh, reading the problem explains the problem. We better say that too. If I have a double exclusion, then you have a double union. I saw that on a couple of tests. There was a couple of us who didn't have our unions in between these things. Okay, my domain. From negative infinity all the way to negative 3, I can't equal negative 3. So I put a union at it and then continue going. I also can't equal 3, so I need a union there. Okay, because those are my vertical asymptotes. It should be a number line when you write it left to right. Okay, left to right. See how it's a open circle at negative 3 and 3? Because that's my vertical asymptote. That's the one spot it can't equal. Those are the only people who are going to eat my goldfish. They're not allowed to my party. So, yeah, yep, that one. Let's do that one. If we can do that one good, I don't think we need to do the other. We've run into this before with our rational functions. Very first thing you should be doing, factor, factor, friggin' factor. Okay. Factor what you can. Zeros of numerator and denominator. So this is how my keys usually look. I have both the original and the factored form next to each other, so that these will tell me horizontal asymptotes at plus or minus 1, or vertical. Words are hard. Oh, okay, yeah, that one's fair. X equals -1, x equals 1. Okay. I'm going to have X-intercepts are zeros of my numerator. Plus or minus 2. If I do h of 0, it's just 4/5. For my y-intercept. And because my degrees are the same, then I'm going to put a little 1 here and say my horizontal asymptote is y equals 1/5. Okay, so I found my 4 things. Now you just need to go to your calculator, look at the table, get a couple more points in there. And in this case, I don't think it's even worth it because those points are so small that I could just go make my graph. It's going to skirt along here above the x-axis, then shoot straight down. Real tight against that axis, and then right in that narrow little corridor. And there you go. Okay. So again, if I'm checking this on daily quiz, I'm checking this on your quiz on Tuesday next week. I'm looking at vertical asymptotes, horizontal asymptotes, x-intercept, y-intercept, general shape is correct. Okay? Make sure that you're labeling stuff. How we feel about that when they're the same? Show me thumbs. Like, we're good. One more. Getting a little dicey. Okay. Did I have one back here? 2, 1. Oh, okay. We're going to get more of those when we do ones with holes in them.
You forgot to do the domain on the last one, so is that a blank one?
Y'all getting ruthless.
Hold on, did you miss a graph?
I wrote the one up there yesterday. I did not write the one from just now. And where is black? Who keeps stealing my markers? Is there a black one back there? I don't want red. I want black. It's all the goobers in here at lunch for game club. They're always drawing all over my boards.
I blame someone else for that one picture on that board.
Defense. Defense. Negative infinity to -1, union, -1 to 1, union, 1 to infinity. Okay? Bunch of vultures. All right. Okay. Oblique asymptote, like we already said, you're just going to divide and ignore the remainder. The other thing, and we have run across this already, when I say to factor it, it's because you might be able to remove a factor. When I remove it, we know that as removable discontinuity. But in terms of the graph, it creates a hole. Do you remember something about holes? Yeah? They're not in the domain. In the calculator, they will not show the hole. I think, I forget if it was first or second hour, I zoomed in on it. Like, the window was 1,000th in each direction, and you still couldn't see it because the calculator's only got so many pixels, and it's saying not at 3, not at 3, but it's at 2.9999999. It's at 3.0000001, and it just can't show that gap. Okay? So when there's a hole, we have to remember it. So oblique and holes, here we go. All right. If I can factor it, factor it. 2x to the third over x plus 4x minus 3. So I'm going to have a vertical asymptote at -4 and +3. 1, 2, 3, 4. I'm going to have one at 3. Okay. What else?
Will that be oblique? Or like,
It will be oblique. Yep. Because when I try to do horizontal, the rules say I check the degrees. I now have n is greater than m, so I need to divide. I'm dividing by a quadratic. You got to know linear, or you have to know longhand. 2x to the third, 0x squared, 0x, 0. X squared plus x minus 12. Divide. 2x cubed divided by x squared. X. X times the stuff. Oh, 2x. It's 2x to the third, 2x squared, negative 24x. No. Change my signs. Negative 2x squared plus 24x. Drop a 0, I guess. Negative 2x squared divided by x squared is negative 2. Negative 2 times the stuff is negative 2x squared minus 2x plus 24. Change, change, change. Who cares? What?
Once you get the constant on the top of the quotient, can you just stop?
Because we don't care about the remainder, right?
Yeah. Since you don't even have to.
I would finish it off just to make sure that there isn't a remainder. Because what if you didn't see the hole yet? What if you didn't factor, you just saw the degrees and immediately started dividing? If you get all the way to the end and there's 0 as a remainder, you're like, oh wait, crap, that's right, there's a hole. Yes and no. Like, if you know that this is going to happen, don't worry about it. Don't finish it. Like, just write angry face of doom. Okay? So I'm going to have an oblique asymptote at 2x minus 2. If I remember right, yeah, because that's going to be way down here. I'm going to have a portion of my graph way down in the corner. Just to save us the headache, I'm going to go by 2s so we can actually fit everything. And say my oblique asymptote start at negative 2. Slope is up 2 over 1. And I'm going by 2s, so there we go. It's going to look like a slope of 1 because of my scale. See that little triangle wedge down there? I wasn't going to see the other part of the graph if I didn't have a big enough scale. Either you would have had to gone really off-road, or we have to change the scale. Okay. What else can I find? I've got vertical asymptotes. I got an oblique asymptote now. I can find intercepts. If I set my numerator equal to 0, I get an x-intercept of 0. If I plug in a 0, 0, 0, 0, 0, 0, well, I get 0 again because my x-intercept is 0 means my y-intercept has to be 0. So I got nothing else. How do I know if this does one of these numbers? Or what if it instead does one of these numbers and happens to go through that oblique asymptote? Grab the calculator and double check. Go find some more points. Y is, clear, 2x cubed over, crap was it? X squared plus x minus 12. X squared plus x minus 12. There we go. Go to my table. Oh boy. There's some fun numbers. -6, -24. So I know that's way downtown. Oh, but -3, 9. I can plot that. -3, 9. I can do this. Is by twos. 1, 2, 3, 4 and a half. Clink. Foul ball. Okay. -2, 8/5. -2, 8/5 is almost 2. Keep scrolling down. What about at +1? Yup, -1/5, -8/3. So it does at 1, -1/5. At 2, -8/3, so -2 2/3. It does go through. They have opened the shield. Okay, I went and found a couple more points, and at -1, 2, 3, 4, 5, that was one I could see, right? -31 1/4. I still can't fit it on here. So this one's way downtown. Connect your dots. Go find some more points. What do I got past 3? 416, I can put that on there. 416. 5, what is that? 10, 30, almost 14. So it's going to do one of these. Okay, don't have to be perfect. I've just got to see enough to see my curvature. Okay. You might want to make a note next to this. Make sure you're finding points and not just winging it. Like those purple sections in the top right and bottom left, you need to know how far into that armpit is your graph going. Because see how this wasn't all the way down into the V? If you come at me with a graph that looks like this, and it wasn't supposed to, well, then you're going to miss 1 point for having a graph that is non-proportional. Okay? So just go find a couple more points. That's all I'm asking. Doesn't have to be a work of art. Doesn't have to be perfect. I found, what, 1 here, a few in the middle, 2 back here. Just enough to see where my curve is. So, perfect. We're going to do 4A.
You didn't do the domain.
What?
Since we did the domain.
That's 20.
Yes. Do 4A. Just. All right. No, that's what happens. You got it once. I text my wife. I tell her we need brownies. Now it starts over, and now it's up to 25. Go! 4A, get it. You should be doing 4A now.
That's not bad. So then I have a question. Okay. So this is what I got. My calculator won't give me an actual decimal, and I don't know how to put it into a decimal. Should I know how to do that?
Well, yeah, in scientific notation, we kind of beat the hell out of it in physical science.
I never was good at this.
Leave it as is. I know what you mean. We've talked about what that means, but if you want to leave it like that, that works. I'm gonna write it now. Text my wife that my class is picking on me. High school kids are mean.
I'm just leaving it on your desk.
It's done? Okay. Half of 3 is 3 halves. 3 halves squared is 9 fourths. 12 fourths plus 9 fourths is 21 fourths. Solve by square roots. Your x-intercepts, make sure you write them correctly, are negative 3/2 plus or minus square root of 21 over 2.
Okay, can you take that? Let's see. Oh, yeah.
Okay. Now, square root of 21. It's like 4.6-ish. Divided by 2 is about 2.3-ish. I can still use the decimal approximation to plot them. Negative 1.5 plus about 2.3. Okay. Is about 0.8, like meh. Negative 1.5 minus about 2.3 is about negative 3.8-ish. 1, 2, 3, 8. See how they end up real close to those asymptotes? Okay. Go to your calculator, find some more points. You got to find out how far into that armpit is this thing going. Okay. And the bell's going to go ding, so I'm assuming that you did it. Actually, I have some points on there. But maybe you need to highlight this part about if I ask you to label the x-intercepts and you just give me decimals. In the famous words of Marlon and Damon Wayans, homie, don't play that. Okay, y'all be happy to know that my wife also laughed at me. She says, good, serves them right.